All right, so let's go over this. So first page was short answer Unix type questions. So what are makefiles used for? So two of the main functions of makefiles. One, they help you make sure that you're only recompiling things that need to be recompiled. If you have 500 files in your project and you change one of those files and you want to rebuild your executable, you probably don't need to recompile all 500 files. If you say gcc star.c, it recompiles all of them. If you have a makefile that's well written, it will see this is the one file that changed, these are the other things that are dependent on it, and it will just compile the pieces that need to be recompiled. So only compile the parts of a project that need to be compiled. And it also makes it simpler to rebuild your project because all you got to say is make, enter, right? 5 keystrokes and your project gets rebuilt. And the make file figures out, I got to compile these things, I've got to link these two things together, and so on and so forth, right? So you don't have to think about that, you just say make. So answer to that was actually both 1 and 2, so number 3. The echo $x command, so if x equals 12 plus 3, it just echoes 12 plus 3, right? Completely literal. If you use the $paren, it evaluates 12 plus 3 and it echoes their sum, which is 25, not 24, not 26, by the way. But I didn't take off for that. If you say x equals single quote stuff, it just echoes that stuff, right? Because a single quote suppresses evaluation of the $. GDB, so you're running GDB, you want to set a breakpoint at a function called myfunc. You can just say break and the name of the function. Or if you know the line number of that, you could say break line number if it's in your current file. But either way, it sets up a breakpoint, and it basically says if I'm running and I get to this function, I should pause, I should come back to the user, and I should wait for a command. Okay, so that's a breakpoint. Execute code until you reach the breakpoint. If you're just starting, if you just got into GDB, you would want to say run or start. If you've already been running and you just want to continue running until you hit the breakpoint, you could say continue. So any of those would get you credit. Examine the value of a variable named myvar. That would be print or p myvar. You can also use display, even though we haven't talked about that. But x does not do that. Okay, x looks at a memory location, and it'll look at a memory location whose address is given by myvar, right? And that's doing something different. So you want to use a print here to actually look at myvar. And then continue executing your code after a breakpoint. I was kind of looking for continue, right? But if you said step or next, I gave you credit for that. But these don't just kind of let the program keep running. They execute a single piece of your program, and then they come right back to you for more instructions. Continue says start executing more and keep going until you hit a breakpoint or an error or the program exits, or you need to read from the user, right? So that lets you keep running. So now these questions about x and the echo statement. So if you say x equals pwd, right, x is equal to those 3 characters, pwd. When you say x equals $x, well, $x is the value of x, that's pwd. So this is really saying x equals $pwd, which means execute this command, capture standard out, and set x equal to whatever that command returned. So now when you do this echo statement, echo $x, it will show you the output of pwd, which is your current directory. So any answer along those lines would get you credit. So x equals pwd, right? X is just x, $x is pwd. If I say, let's just do y equals $x, right? That's the result of executing the command pwd. So it shows you your current directory. So single Linux command to change the name of a script from my script to main, that's just the move command. So move old new, changes the name of this file to be this, right? You can do a copy and then remove the old, but that's two commands and it's not actually renaming. It's making a new version of the file and then getting rid of the old. And so it changes the creation date and time and possibly the owner and all sorts of other things. This is actually a rename command. It's just move. Why do you put the shebang at the top of a script? The only reason you do that is to force your script to be run with bash, right? If bash doesn't exist on your system, this will give you a file not found when you try to execute your script. It does not add anything to your path, and it's not just a comment if it's the first line, right? So 3 is the answer there. And then creating a tar file named archive to put those files into a single archive. So tar is the command cvf, and mainly you need the C for create and the F to say I'm going to tell you what the name of the archive is, and then the archive name, and then the files that you want to put into it. So main.c, print.c, print.h. And this is saying, here's the archive, here's the pieces going into it. Now, if you put this at the end, if you say tar cvf main print print archive.tar, you're saying main.c is the name of the archive. It gets rid of your current main.c and it replaces it with a tar file. And your main.c is gone, right? So you've clobbered your main program. So first thing after cvf has to be the name of the archive. This does not get a dash in front. I didn't take off if you put a dash. Most Unix commands have dashes in front. Tar doesn't, right? It's just cvf. If you do a tgz and you did it correctly, I gave you credit, but that's actually a gzipped tar file. Technically, it's kind of like a tar file, but if you do a -o switch, your archive is called -o, which is a little odd. All right, so let's talk about the programming questions. So your first C program is supposed to count the number of times that this character occurs in this string. All right, so it's a function, takes a character in a string and returns an integer, which is a count. And as I keep saying, there are a lot of different ways to do any of these. So let's look at one. So the first argument is a single character, which I'm calling ch, but you can call it whatever you want. The second argument is an array of characters. If you're prototyping, you put a semicolon at the end. And it says, I'm not defining what the function contains, I'm just telling you what the function looks like. But since we're actually writing the function, no semicolon, opening curly bracket. Well, we want to count how many times something happens, so we need some sort of running sum. So I'll just call this a number, num. I'll initialize it to 0. And the basic algorithm is let's go through each character of this string str and see if that character is equal to ch. And if it is, I'm going to increment this running count, and then at the end I'll just return the count. So how do we loop through the characters of a string? You can do a for loop or you can do a while loop. Those are sort of your two options. I said you're allowed to use string length, which was a nod to using a for loop, but let's do this both ways. So for I equals 0, I less than string length of string I plus plus. So this is going to take us through each character of str, and our goal is to see if that character is equal to the character we're looking for, which I call ch. So if string I equals ch, let's just increment our count. And then when we exit the for loop, we can just return that counter. And there, we're done. Now if you want to do this with a while loop, right? We can initialize our index to 0 outside of the loop and then say, well, character I or string is not the null terminator. And then we can do all of the usual stuff. See if character I is the character we're looking for, increment our number. And don't forget to increment I at the end. They probably code identically into assembly language, right? Because algorithmically, there's really no difference. So things that went wrong here: not initializing your count, right? So from ODPs, you've seen sometimes you get crazy numbers if you don't initialize. Make sure you initialize to 0. If you're looking for a null terminator, it's a character, right? String bracket I is a character. Make sure you put a character over here. That's single quote /0. If you use a 0, that's actually an integer, and you're trying to compare a 1-byte character to a 4-byte integer, and you'll at least get a warning, but you might get some weird results there. If you increment I at the top of this while loop before you check character I, you're skipping over the first character, right? So make sure that you're building this while loop like a for loop, right, where you're doing the movement to the next character after you've already dealt with the current character. Several people did this. They tried to compare character I to single quote CH, right, which is off for a few reasons. One, this will give you a compile error because you can't have two characters as a single character. And CH is just a variable name, right? The character you're looking for is whatever this first argument was, that's just CH, right? So that's a character, you can compare those. Make sure you use double equals for comparisons. If you use single equals, strange things happen. Some people threw in things in the middle here like increment string bracket I or increment CH, and that looks like stuff that we sometimes do, but it really doesn't make any sense here because this is changing the incoming argument. It's bumping up the ASCII code of each character by 1, which is probably not what anybody intended. This is changing the character that we're comparing to each time through the loop, and that's doing something very different from what you're supposed to do. So those I'm not sure what the intent was. If you're doing a for loop, right, it's I less than length of string. And make yourself a test case, right? So suppose str is equal to cat, right? So C is character 0, A is character 1, T is character 2, the null terminator is character 3, and string length is equal to 3. It's the number of characters, right? So put this in your brain or put it on your pages of notes or something, right? When you're trying to figure out, should I go up to string length, should I do less than or equal to string length, and so on.
Shouldn't it be less than or equal to?
So if you do less than or equal to, I will, in this case, I would take on a value of 3, right? And character 3 of my string is the null terminator. So I'm comparing the null terminator, and that's not really part of the string. It won't do any harm, right?
So string length counts the null terminator.
It does not. So if my string is CAT null terminator, string length returns 3, CAT. But that means the last character is actually at, in this case, index 2, string length -1. Okay? So I always have something like this either written down or in my head, just a test case to know, should I do less than or equal to, should I do less than string length -1, right? Those are sort of your 3 possibilities. But a small test case can help you double check your logic. Pet peeve, don't do this, for I semicolon, right? The thing that comes before that first semicolon is your initialization behaviors, what you want to have done at the start of the for loop. And this doesn't do anything, right? The compiler will look at this and it will just ignore it, right? I is not a state, I mean, it's a legal statement. It doesn't do anything. It doesn't change the value of I, right? And if you said up here, you know, integer I equals 0, and then you say for I semicolon, the I semicolon is meaningless, so this is perfectly valid, right? For semicolon with nothing in here in the beginning, right? To say I don't need to do any initialization here. But a better way to do this might be for I equals 0, I less than, etc. Because the problem with this or this is when you're looking at the code, you got to work your way backwards and figure out what the last value was that was assigned to I. And if this is near the beginning of your code and there's an int I equals 0, then it's not too bad to figure out I is equal to 0. But now you come along and you decide to throw this thing inside a while loop, your code's going to break because you're only initializing it when your program starts, right? And in your mind, you're seeing this as I equals 0, but it's really not. So it never hurts to do this, right? It just makes it a little clearer, and your goal is to not make your life miserable, especially down the road. All right, so, and if you got any questions, just like ask while we're doing this. So next program, write a C function named smallest that returns the smallest of two integers. So this mostly worked well. So I'll just call my inputs A and B. And what do we want to do? If A is smaller than B, return A, otherwise return B. So that works perfectly fine. The else is actually not necessary, because if A is less than B, you're not going to get to this next statement. You're going to return from your file, from your function. So if A is less than B, you're going to return A. So I could really just say return B. Doesn't hurt to have the else. And if you're someone who likes doing things in one line, you could really just say return A less than B, interrogate A colon B. There's the one-line version using a ternary operator. So if A is less than B, it returns A, otherwise it returns B. But that really just kind of expands to that. So here's where people started to get into some trouble. Alright, so the problem here is if A is equal to B, you don't specify anything that you should return. And if you're assigning some variable equal to your return value from smallest, that variable is basically whatever the last return was that you did from any function. So it's going to be something kind of weird. So you could fix this. Right? And that works, but it does the same thing as this, does the same thing as that, right? But you've spelled out all of the cases. Similarly, you could put else statements here, but it doesn't do anything different, right? And in some cases, there was an extra else down here that printed an error message. And yeah, that should never happen, right? A is either going to be less than B, bigger than B, or equal to B. So this should never happen. And doesn't do any harm to have that there. Except I did this once and I had a case that I thought should never happen. And my else statement printed out rip in space-time continuum. And about a year after I left the company I wrote this for, I got a call from someone saying, your code just reported a rip in the space-time continuum. And they had updated the operating system, and some condition that never should have occurred was now possible. And it actually did occur, and they got this weird error message that space was being torn apart. So any of those are good. So a few cases, the sense of this inequality got reversed, and it actually ended up printing out the largest of the two numbers instead of the smallest, right? So throw a couple of numbers in and work through your code and make sure it's actually doing the right thing, because it's easy to flip those. So I should say up front, I forgot to mention this in the beginning, right? I was really happy with everybody's performance on the exam. Like in most cases, I think everybody's doing the right stuff. There's lots of places you can get kind of nickeled and dimed, right? There's little things that can happen here and there, and those 1 or 2 point deductions can add up, and you end up with a grade lower than you expected maybe. But as far as basic algorithms and basic structure of programs, right, most everything that I saw was like really good. So I was actually pretty encouraged with what people were doing. All right, so one more C program. So question 10 was dealing with command line arguments. So main program that expects a command line argument and does the following. If there's no argument or more than one argument, print out the error message no arg. If there's a single argument but it's not an integer, print out no int. Otherwise, take that integer and print out either a 1, -1, or 0 based on whether the number is negative, 0, or positive, and then exit. So command line arguments, you got to do argc, argv. Okay, there's no choice. So integer main, integer argc, char ** argv. You can call it anything you want, but argc, argv are sort of traditional. But you could call it, you know, Fred and Wilma or something. Doesn't make any difference. So what do argc and argv do? If you run your program and you say main 215, this tells you argc is equal to 2. Okay, it tells you how many things were on the command line, including the program name itself. It's different from bash. Okay, so this is something good to put on your note sheets if it's not ingrained. So argc equals 2 for this. So just put down a few examples and list argc. And in this case, this first argument is argv bracket 0. The second argument is argv bracket 1. Okay, so I listed these conditions in the order in which you want to evaluate them, right? We don't want to see if the first argument is an integer unless we know that we have a first argument. So the first thing we do is check to see if there's an argument given and make sure that there's only one. Okay, so we want this. We want your program run with a single argument. That means argc should equal 2. So here's a straightforward way to check this. If argc is not equal to 2, print an error message, which is no arg. And it says the program should exit after printing a single line of output as described above. So we've printed no arg. We're allowed to exit at this point, right? So what I would do personally is I'd return. Okay, you don't have to return right there. You can just have a closing bracket, and then you can say else, and go on to your next condition, see if the argument is an integer, and if it's not, print an error, right? Close bracket, else, etc., etc. I'm lazy, right? I keep telling you this. I don't like thinking too hard about certain things. I don't want to have to keep track in my head of how deeply I'm nested inside a big if statement that goes on for 30 lines, right? My reason for putting a return here is that's the end of the if statement. And I know this if statement checks to see if there's a problem with the arguments, and if it is, it takes care of it. Otherwise, you have exactly one arg. And now I'm working at this part of my program specification. A single argument is given. And I'm not inside brackets, I'm not inside a big compound if then else statement, right? This is just sort of top level code now. So you can do it different ways. You can have a bunch of else's, you can have things nested inside each other, right? But to me, the more I avoid that, the less likely I am to make mistakes. So I'll return there if I'm done, otherwise I'll just go ahead and continue. So the next thing I want to do is if a single argument is given, but it's not an integer, so I want to see if I have an integer. How do we do that? scanf, okay? So some people went crazy and started trying to parse this argument by hand. Check to see if the first character is a dash. Check to see if it's a digit, and march all the way through until you get to the end of it, and set a flag if it's not a digit, and so on and so forth. That's a lot of work, okay? You can do it. In some cases, people got pretty close, but it's going to take you time. You got 50 minutes for the exam. Use scanf, okay? I think everybody here did, because I keep saying this in class. But you know, make life easier on yourself. So let's use scanf. So I want a number that I can parse into, and I want to save the return value. And what I want to parse is argv bracket 1. That's the one argument to my function. I want to parse with a %d. You can do %i, it's the same thing, but I've been using d. %lf is for a floating point. Okay, an integer will parse as a floating point, but it will assume that this last argument is a float or a double, and you'll get weird numbers. So if you're doing integers, stick to d or maybe I. Okay. If you do a to I, ASCII to integer, that doesn't tell you if you have an integer or not. If it's not an integer, it'll convert to 0. But if it's a 0, it'll also convert to 0. So there's no way to look at the result of a to I and know if you had a valid integer or not. So scanf does that for you. So convert your first argument as an integer, store the result in num, and let's see how many things we converted. So how do we know if scanf succeeded in this case? Yeah, see if the return value equals 1. So if the return value is not 1, what do? Well, we print out the message no int. And we return. Again, you could do this differently. You could say if return equals 1, and then do these three cases. And then at the bottom, you could say else print no int, return 0. But that's going to require me, when I'm writing this and reading it, to keep in mind the idea that if ret's not 1, I got to skip until I get down to here, and then I do this else statement, right? I don't want to keep things in my brain like that. So I'm going to write this in a way that lets me deal with this case and then forget about it, right? So now if I come down here, we have a valid int. Okay, this is all personal choice. This is just coding style. This is algorithm style, right? And it's different for each person. And there are people who think of things differently, who might actually prefer to, you know, have the major cases at the bottom. But find the style that works for you, right? Find the approach that makes it easiest for you to keep things straight. And experiment. All right, so we have a valid integer, and that integer is in this variable num. So now we need to say if it's negative, print a 1, if it's 0, print a -1, if it's positive, print a 0. And that's just a few if statements. So if num is less than 0, then print 1. Else if num equals 0, print out a -1. Else, well, I could say if num is bigger than 0, but I know if it's not less than or equal to 0, it must be bigger than 0, because those are the only three possibilities. So else, print a 0. And I might put a comment here. Num must be positive. Right? So when I come back to this in 5 years, it's like, oh yeah, okay, that's why I didn't have an if statement there. And then just return. All right, so other issues I saw here, there's no place for fgets in here. Okay, we're not reading from standard in, we're being given a command line argument. It's already a string, we don't need to use scanf, we don't need to convert it to a string or anything like that. It's a string, we can immediately throw it into scanf and parse it as an integer. Don't need to read anything. If we don't have this return statement here, we risk a seg fault when we get down here. We don't have the correct number of arguments, we print an error message. Now we try to scan argv bracket 1. What if we didn't have an argv bracket 1? That's going to seg fault. Right? So either put an else statement and put this inside an else block, or kick out of your program up here. Same thing down here. If return is not -1, either return or put all of this in an else block. Because num will have some value, it just won't be a value associated with an argument, but one of these statements is going to print something, right? So put that in an else or return when you find that you don't have an integer. Small issues, right? Thinking argc should be 3, thinking argc should be 1, right? Again, put something on your note sheets with a couple of test cases just to refer back to. And don't be afraid to use things like not equal, right? The majority of people said if argc is less than 2 or argc is bigger than 2, which is really just another way of saying if argc is not equal to 2, right? But it's just exclamation mark equal means not equal, right? So if you're not comfortable with that, throw that on your note sheets and practice using it. Don't just say if scanf or if not scanf, right? You got to do more than just see if this is 0 or non-zero. Because if your argument is an empty string, this will be non-zero. If your argument is ha, this will be non-zero, right? If your argument is an integer, this will be non-zero. Sorry, if it's ha, it'll be 0. If it's an empty string, it'll be non-zero, -1. If it's a valid integer, it'll be non-zero, +1. So you can't just say if parentheses scanf, right? Check to see if it's equal to 1 or if it's different from 1 to know if it succeeded or failed. Right, and make sure you're using argv bracket 1, not just argv. Definitely not argv bracket 0, definitely not argc, right? Argv is the array of strings. Argv bracket 1 is a string corresponding to that first argument. All right, so let's look at bash. So 2 bash programs. First one was trying to print integers between the first and second command line arguments. So almost everybody did a shebang at the top, which is great. So when you run a script, your arguments are available under $1, $2, and so on. And I told you in boldface that you can assume both arguments are given, they're integers, first is less than or equal to the second. So you didn't need to check $number, you didn't need to compare the two integers and swap them and so on. A few people did. Again, nothing wrong with that, it's just taking extra time that that's pretty precious. So we want to loop, we want to basically start with $1, print it out, increment it, keep going until it's bigger than $2. Okay? We can't say $1 equals $1 plus 1, right? We can't change the value of $1, so we need a different variable. So I might do something like, number equals $1, and then while our number, and we want it less than or equal to whatever that second argument is, because we also want to include that second number, right? So while this condition is true, echo the number, and then let's increment it. And there you go. So num equals $1, as long as that's less than or equal to $2, which we've been told it is, it'll print out that number, add 1. And as long as that's not bigger than $2, it'll print it out, add 1, and this will run through. And when num is equal to our second number, this condition will still be true, so it will print out that second number. And then it'll add 1, and now num is going to be bigger than $2. The while condition fails. We kick out of the while loop, and we're done with our script. So issues with that. There were lots of issues I saw with this. So not doing the while loop correctly, using parentheses, using single brackets, using single parentheses, not having anything in here at all, right? Those are all big deductions, right? You got to know how to write a while loop, right? And we've gone over this, and I told you to put it on your notes. So put it on your notes if you don't know how to do this. While space, bracket, bracket, space, condition, space, bracket, bracket, right? And you can't have gotten anything done in Bash with looping unless you've done this at least a few times. So make sure you know how to do that. Make sure you're using $signs when you want the value of a variable, okay? That should be pretty much second nature at this point, because you can't really be doing anything in Bash without using the $signs. If you do something like num equals single quote $1, that's not what you're after, right? Single quotes stop the $sign from being evaluated. And this will just set num equal to $sign followed by 1, right? So that's not what you want. You could put double quotes, or you could have no quotes, and that's fine. Minor algorithmic things, putting an extra echo at the end where you echo $2. Well, if this is less than or equal to, this loop is going to print out $2, and then if you echo $2 at the end, you've got that number printed out twice. If this is less than, then you need an echo $2 at the end.
So I have the less than, and then I put the echo second number.
At the end?
Yeah.
Okay. Was your less than dash LT?
Yeah.
Okay. Show it to me after class. I'll give you points. So yeah, if you do less than, you can echo at the end. If you do the increment before the echo, right, if you swap the order of these two statements, you're going to skip the first number and you're going to do one too many numbers, right? So think about the logic, and you're really making a for loop here, right? You're saying for number equals $1 while it's less than or equal to $2, number equals number plus 1. For loops, the increment comes at the bottom. If you didn't lose points, it doesn't necessarily mean you did things it doesn't necessarily mean you understood exactly what you did. Because I saw some things that actually worked, but were totally different from anything we've ever gone over in class. And there's two possibilities. One, you're already really good with Bash, and you just know how to use Bash, and you're just using things that you've already learned. And that's great, okay? If that's the case, no problem. But if you didn't know what to do and you took a shot and you got credit for it, right, make sure you understand what you did. So here's one I saw. Right, instead of num equals $, paren, num plus 1, parentheses, parentheses, num plus plus, two closing parens, no $, nothing on the left-hand side. This actually works, okay? But it's so different from everything we've ever done with doing arithmetic in Bash that if you're not sure why this works, I would say don't do it, right? Stick to something like this. But if you got lucky, you got points for it anyway. But like I say, if you know what you're doing, keep doing it. But if you weren't sure, ask, and we'll go over it. All right, and then one more Bash program, which was reading input, making a running sum, and looping until the sum is bigger than 20. So again, shebang at the top. We need a running sum, so we've got to initialize something. So let's just call it sum equals 0. And we want to loop until the sum is bigger than or equal to 20. So let's say while bracket bracket $sum is less than 20. Right, because we want to exit when it's greater than or equal to, so we want to loop while it's less than. So do. And then the description is to read a number, add it to a sum, print the sum. So let's say read num sum equals num plus sum. Echo sum equals $sum. And then when you're done, echo done. So different ways you can do this, right? And the usual mistakes from the last time that can go wrong, right? Echoing before you've done the read and the increment, doing the increment after you do the echo, switching around the order of those things. Doing a less than or equal to here allows the sum to be 20 and keep going, and actually as soon as the sum equals 20, it should exit after it prints out the sum. So that's got to be less than. If you make this greater than or equal to, that's definitely not right, because since sum is 0, if you say do this while sum is greater than 20, it's never going to do the while loop, right? So easy mistakes to make, easy mistakes to fix. Don't do a read dash n1, right? Read dash n1 says read a single keystroke and then come back, which means if I try to type in a number like 15, I'm going to type the 1 and it's going to come back and say you entered a 1. Right? It's a nice fancy thing to do with high-low where you just want a single keystroke, but in general we don't want to do that. You just want to read some number, let the person type till they hit enter. What else in here? That's pretty much the bulk of it. Again, things that people did that I'm not sure they necessarily knew. So one person did this, while bracket true, and then inside the while loop they did this test with an if and they did a break, right? Well, this does work for an infinite loop, but this also works for an infinite loop, right? It's not actually looking at this and saying this is true, so I'm going to loop, right? Because it's called true. It's actually looking at it and it's saying, well, it's not missing, it's not blank, so it's true. Right? So if you're doing something like this, make sure you know what you're doing and why it works. Okay, and the fact that you got credit for it, or the fact that you did this in code and it did the right thing, doesn't necessarily mean you understand it. Okay, the stuff we've been talking about in lecture, I've been trying to explain why it works, and hopefully you understand, why this will loop until the sum's greater than or equal to 20, for example. But the other stuff that I'm seeing, right, just make sure you understand what it's doing. Because if someone asks you in a job interview, right, you don't want to get tripped up on that. Or a future test. All right, we got a few seconds to do Lab 4. Oh, no, I don't want to tell you about Lab 4 yet. Let me tell you your extra credits. So I posted an announcement, extra credit opportunities, today at 2 o'clock, 3 o'clock, and Thursday at 3 o'clock. Come to a teaching demo, 5 points each. Okay, I believe they're in room 126. I think these odd will have a sign-in sheet. Show up, you can get a maximum of 15 points added to your lab score. So it's something like 1.5 points on your final score if you go to all 3. So cheap extra credit opportunity. Go ahead and check that out. And basically people are coming in to interview for jobs, teaching. And so they do a teaching demo. It's like 10 or 15 minutes usually. You pay attention, you might ask some questions, and then I think you fill out like a 1-page just kind of synopsis of your impression. And it helps us do a better job of hiring teachers for some of the courses here. So if you can come to those, it definitely helps out the department, and you get some extra credit for it. All right, so Lab 4 is posted. There's no Lab 5, so Lab 4, you get 3 weeks, it's 40 points. And we'll go through the details of it tomorrow, but it should be a pretty fun lab. Look it over, and we'll talk about it in class tomorrow. All right, I will see you then.